So today we will discuss about CT polarity and its importance in protection system, and the next important thing, why the star points in the are always made towards the protected object side. So first, there are only two basic things: P1, P2 and S1, S2. These are the primary and secondary terminals of the CT. And the two basic rules are: if the current enters through the P1 terminals on the primary side, then it will always leave through the S1 terminal of the secondary side, and vice versa. If the current leaves from the P1 terminals of the primary side, then it will enter through the S1 terminals of the secondary side. And some of the utility, they are using this dot convention, but at most of the power grid and most of the Indian utilities, the convention is P1, P2 and S1, S2 for the primary and the secondary side. Now the next important thing, why the star points are always made towards the protected object side, is that there are basically three types of protections. One is the distance protection used in the transmission line. Second, the differential protection of the transformer, reactor or bus bar. And the last, the REF protection of the transformer and reactors. Now if we are not making the star point toward the protected object side, then the limitations are that either the directional protections, which depends upon the CT polarity, it will not operate correctly. That means the relay will detect the forward fault in the reverse direction, or it may detect a reverse fault in the forward direction. Second thing, differential or REF protection may maloperate. That means the differential protection may operate in case of an external fault, or it may not operate for an internal fault. And the last important thing is that in case of the distance protection, the relay will not operate correctly, because the directional element of the distance protection scheme or the distance protection relay will not detect the correct direction, and it might operate for a reverse fault in the forward direction or for a forward fault in the reverse direction. Now we will see how this happens. This is the first condition of a differential protection relay, and how the CT polarity determines the correct operation of a differential protection. Now this rectangular box is simply showing us any transformer of any MVA ratings and any voltage rating. In our case, it is a 765/400 kV 1500 MVA ICT. The two CT at the two sides of the transformers that we have shown here, that is CT1 of the HV side and CT2 of the IV side. P1, P2 of both sides are the terminals, primary terminals. Now if this polarity is correct, that means all these connections are correct. And now we consider the first case in which this fault is external to the ICT. That means fault is in some other feeder or at the bus bar. Now if the fault is external to the ICT, then what happens? This first CT will feed the current like this way. Second CT will also feed the current this way. In the primary side, current is entering through P1 terminals, so it will leave through the S1 terminals in CT1. CT2 current is leaving through P2 terminals, so it will enter through S2 terminals. These are S1, S2 of primary, S1, S2 of secondary. And now if you look at this point, then what happens? This current coming from CT1 and it will go directly to the CT2. Similarly in this direction also. So there will be no current in this relay. If there is no current in the differential relay, then it will not operate. And this is a correct operation, because this is an external fault, so relay must not operate. Now in case of the internal fault, suppose fault is somewhere inside these two CT zones. Now what will happen? Now the fault is inside these two CT. So this CT1 will feed the current like this, CT2 will feed the current like this, and if this is P1, P2 of the primary and this is P1, P2 of the primary terminals of CT2, then since current is entering through P1 terminals of CT1, it will leave through the P1 S1 terminals of CT1. Similarly in this CT2, current is entering through P2 terminal, so it will leave through S2 terminal. And now if you check at this point using simple KCL, the total current that is coming from this CT1 and again through this CT1, so total current I am showing two arrows, that is arrow 1 for CT1, arrow 2 for CT2, and there will have some current through this differential relay, and that current will depends upon the fault magnitude, and if this current is more than the setting of this differential relay, then it will operate. And this is a correct operation because it is an internal fault and relay must operate. Now this is case 3, and why it is case 3? It is simply the same case as the last one, and here only one thing is done, and that is we have reversed the polarity of the CT at the port's end. Now again the first condition, this is an external fault, and in this case what is this? This is CT1, CT2, and again P1, P2, P1, P2. And now if you look at this point, then what I have done in the last case, these two internal side windings of these two CT were connected at this same side. Now here this P2 is connected to the internal side, that is P2 of CT1 is connected to the external P2 of CT2, and similarly the external side P1 of CT1 is connected to the internal side P1 of CT2. That means this is a reverse polarity as against the last case. Now by the similar logic, if there is an external fault, and if you see, this CT1 will feed the current like this, CT2 will feed the current like this from the primary terminal, and in the secondary, since the current is entering through the P1 terminal of CT1, it will leave through the S1 terminals of CT1, and at this point current is leaving through P2 terminals of CT2, so it will enter through the S2 terminals of CT1. And now if you look at this point, what happens? This current is coming from this side, and now this current which is coming from this side, it has to go through this relay, or it must pass through this relay, because now it cannot go directly to the S2 side because of this reverse polarity. Similarly for this side, there is a current like this. This is the current S1, and this current it is coming here, this current it is coming here. So we have CT1 current contribution, CT2 current contribution, and total current inside the differential relay is something like this. And if this is more than the setting, then relay will operate for an external fault. For an internal fault, likewise, you can see that for an internal fault, relay will not operate even if there is an internal fault and CT polarity is not correct, so the relay will not operate. Similarly, we can draw this or by the same logic we can see for REF protection, we can see for different types of bus bar protection. Now the last condition is the distance protection. Now suppose these are the three conductors, or these are the three lines R, Y, B of a single feeder. Now there are three CTs in R phase, Y phase and B phase. In the first condition, what we are doing is we are making the star point towards the feeder side or towards the line side. This is because we have to protect the line, so we are making the star point towards feeder side. Now this is feeder is towards P2 side, so we have made the star point towards S2. And now for a forward fault, this is the forward fault, so CT will feed the current like this. Since the CT is feeding the current from the P1 to P2 in the primary side, so now in the secondary side, since the current in the primary side is entering through P1, so it will leave through S1 terminal. And if you draw like this, so we can see that this current coming from this end, it will go to the relay R phase terminal, and then from the neutral terminal it will come out, and then it goes like this. So in the relay side, what happens that the current enters through R side, or enters from R, leave from N, and in this way the relay determines that since it is an RG fault or RN fault and current is entering from R terminal, leaving from N terminal, that means it is a forward terminal. This is a normal convention used in all type of numerical relay, forward fault. Now if there is a reverse fault, by the similar logic we can see that the current will enter through the N and it will leave through R. And in that case, since current is entering through N, leaving through R, so that means it is a reverse fault by the general convention of a numerical protection relay. But what happens if we make the star point not towards the protection object but opposite to the protection object side? Now in this case, our feeder or line is in this side. This is the line side, but we have made the star point opposite to the line, that is towards the bus side for line protection. Now what happens? This is the forward direction fault. This is forward fault, and the CT will feed the current like this. It is a P1 terminal, current is entering from P1 and leaving through P2, but since current is entering through P1, it will leave through this S1 terminal of the secondary side. And now if you see this current, it is coming through the star points like this. It will enter the relay through the N terminals, and it will then leave through the R terminals of the relay, and it will go like this. So in this case, what happens for a forward fault? This is a forward fault. The normal convention is that the current inside the relay must enter through R terminals and leave through N terminals. But what is happening here is that current is entering through N and it is leaving through R. That means this is inside the relay. So relay will detect this fault as a reverse fault, while the actual fault is in the forward direction. Similarly, for a reverse fault, relay may detect the fault in the forward direction. What happens now is that there is a more than 100% chances that we will have maloperation numerous times in this case of star point connections. Now the first condition is that if there is any bus fault. Now bus fault is not towards line, so it is a reverse fault for the distance protection zones. And now since due to this incorrect star points, relay will see this fault as a forward fault and it will operate instantaneously. Similarly, for a forward fault, relay will see this fault as a reverse fault and it will wait for the reverse fault timer and it will not clear the fault till this time delay. So there will have numerous maloperations due to simple star point connection. So the learning is that we always have to connect, we always needs to connect the CT star points towards the protected object side, points towards the protected object side. And the second, always verify the CT polarity. Verify the CT polarity before taking the relay into service. That's it. Thank you. Okay. Thank you. Done.